Okay,
Perfect.
now it
Perfect.
should be working.
Yes.
Okay, so should we get started then?
Yes, yes, excellent. So, thank you everyone that has joined the call. A reminder, this training today, the training on Thursday will be recorded, so you will have access to it also offline to see how to support you with information on to create a one-click LCA model. And I just want to take a couple of minutes at the beginning just to again welcome you as students and teachers to participate in the next edition of the Architecture Student Contest from Saint-Gobain that will take place in Belgrade, Serbia next year, where you have quite interesting things to work on. Again, the one-click LCA partnership that we have, you will have access to the software to use it when you do the modeling for the new construction in terms of what selection of materials and also analyze the embodied carbon of the project you're proposing. Uh, just to give some information before moving on, please, if you have any questions related to the contest task, to the project, etc., please ask them via the frequently asked questions that we have available, facilitated in the Architecture Student Contest website. And also check that FAQ frequently because there are many questions that might be similar to the ones that you have that could provide, some answers and tips on how to go about some of the issues you might be facing. Again, the objective of the architecture student contest is, to give students from all over the world where Saint-Gobain has activities the opportunity to compete and to participate in a project that is based on a real need from the municipality and from the city, where they take many of the ideas that the students propose to integrate them into their urban planning and the projection for the site. With that, before leaving the hand to Maya to go with the training, again, I want to thank all of you for your participation and hope that these tools that we're providing you in terms of training, among others, help you in your path to be more complete professionals within the built environment. So again, thank you very much. And Maya, I let you continue with the today training.
Good. Thank you, Timo, for that introduction. Um, I don't know if you can see these pop-ups appearing on the screen. Hopefully not. There is something wrong with my microphone, so if for some reason I get cut off and you can't hear me, just let me know. So welcome from my side as well. So my name is Maya, and I work at OneClick LCA as a sustainability or LCA consultant, and I also organize these kinds of trainings quite frequently. So on behalf of OneClick LCA, also welcome. And I hope that this training today and on Thursday will help you get acquainted with the topics of life cycle assessment, theory, and practices. A couple of rules before we get started. So I think I am controlling your microphones anyway, so they are muted by default. If you have the option to turn them on, I would suggest you don't do them. I hope that you will ask questions via it says Teams Q&A, but it means Zoom. So if there is a Q&A tab or a chat tab, please write your questions there. Don't raise your hand because it will just, I'm not going to answer things in the middle of the presentation. So we have a Q&A session or dedicated time for questions and answers at the end. If there are unanswered questions, so if for some reason we get a lot of questions and I don't have time to handle all of them, there is the link to the community. So I strongly suggest you to take a look and go see what's there. And also it's possible to write your questions there and also to like browse through topics and so on. But you can find these kind of like embedded links here throughout this presentation. The recordings and slides are made available the next workday, or probably after the session. So today I think I have time to upload this. to the Academy, and you will find them on the course page. So the same place where you found the link to attend this session, the link will be expired, and then from the same space you will find the recording and the slides as well. Okay, so Timo actually gave his greetings already, so we will just jump into today's agenda. So first, why are we hosting this kind of thing, this kind of LCA training course? And then we'll go through an overview of the course curriculum and talk a little bit about introduction to OneClick LCA, who we are, what we do, and why are we providing these kinds of calculation and assessment tools to you. And then we will have an introduction to embodied carbon and life cycle assessment. And finally, we will have a practical LCA demonstration as well. Yep. So why do we host this kind of building LCA training course? So this course is designed for you as architecture students to give an overview on life cycle assessment, give some background and theory, as well as practical guidance on how to actually deliver an assessment. So your contest task describes that you should also include a life cycle assessment and include also the embodied impacts of the materials that you are using in your designs to actually be able to complete the task. So this is why you also need tools to carry out the assessment. So what you will learn during these sessions is to understand the impact of the construction sector on climate change. You also understand the need for building sustainability and also the regulations that are driving change. You will learn about the core concepts of life cycle assessment, including building life cycle stages, environmental impact assessment, and the data required to perform LCA with hands-on software training. And you will also learn how to use OneClick LCA software and Carbon Designer 3D, which is our early stage design tool. So we will show you how to use these to your advantage. What is included in these two sessions is so we have two sessions as mentioned. So this one and then one on Thursday, and they last about 1.5 hours to 2 hours at a time. So these sessions cover topics on climate change, construction industry, materials, life cycle assessment, and optimization. And yeah, on Thursday, you will have the similar kind of session, same time as now. So what we offer for you is a license to our life cycle assessment software. So this license is valid until the end of the contest, so until the end of June next year. So you will be able to do the assessments in your own time and return to them as you wish until the end of the contest when the license expires. So the course as well will be closed on the last day of June. So you will have also access to the Academy and to these recorded sessions and to the slides and to all the other materials that we have on the course page until that time. And then there is also an exam that opens on Thursday. So the exam has like 22 questions that are all based on topics that are dealt with in these live sessions. So there's no external studies required for this. And you can take the exam as many times as you wish. And when you will pass it with at least 90% rate, you will also get a certificate for building LCA knowledge that you can use. And just to highlight the community page, so this is the OneClick LCA community. So within the community, you will be able to connect with other contestants, ask and answer questions, and just share knowledge. You can also post software-specific comments and questions, as we will be checking the page every now and then. So as well, as I mentioned, if there are some questions that remain unanswered after this session or Thursday session, those will be answered in the community page. So go take a look and keep an eye out for interesting topics. Then some contents. So what we will go through today. So today is the introduction to building LCA and software training. So we will start with climate change and construction, concepts of LCA and building LCA stages, talk about data. So what is an EPD? And then go through also some legislation and standards that dictate life cycle assessment and also the data that we use for that. And then we will go through the steps to create your account and access the software, and then have a demo of the software. And also we have included some self-study assignments, which are not mandatory, but of course recommended if you want to be kind of like gaining knowledge on this important topic of sustainability and life cycle assessment. On Thursday, we will go through how to perform building LCA at an early stage design. So we will talk about how to reduce emissions in practical projects, and then have this demo of our early stage design tool, Carbon Designer 3D. So in your contest task, you had to complete this new building. It was an apartment building, multi-purpose, but for this kind of like optimization in the early phase, Carbon Designer is very good tool to use. So you can use that to, for example, compare different options and set these kind of like carbon baselines and carbon budgets for the whole project. So we will go through that as well. And then also optimizing the baseline results. And I'll also talk about renovation LCA. So the other building was a renovation project. So we will also talk about how that kind of thing is handled in life cycle assessment. Okay, but then let's have a brief introduction to OneClick LCA. So who we are. We are the world leader in construction and manufacturing LCA softwares. So we provide tools to conduct LCAs for buildings, materials, infrastructure, and also for company portfolios. So we've been trying to create this kind of like benchmarking feature and also incorporate some kind of greenhouse gas accounting tools. So the idea of OneClick LCA is to make life cycle assessment as easy as possible. So you don't need years of training to learn to use it. So you don't basically need a PhD. Of course, it doesn't help or hurt if you do have one, but it's not required. So what you need is basic understanding of the construction industry and materials, and then the software just guides you forward. We aim to connect the entire industry. Here you can see some of our customers. So we have clients from the field of engineering, architecture, manufacturing, building, investing, and institutions as well. And to these clients, we provide a global platform for data and tools to make calculations in compliance to certification schemes and regulatory frameworks. So OneClick LCA is a global platform that supports over 60 different certification and regulatory frameworks, and includes also the world's largest data bank of construction materials with over, I think it was something like 350,000 data sets at the moment. So with OneClick LCA tools, it's possible to improve at every project phase, share and connect data. So for example, here you can see the Carbon Designer 3D at strategy phase, and then also at any different stage, you can incorporate data from all different sources and then get your results from that. And then OneClick LCA provides also these free training courses and materials for everyone interested. So we publish reports, policy work, research articles on meaningful matters. And we are a team of experts that are ready to support you in your journey to decarbonization. And because you guys are students, so you are kind of like the core of our audience. So you're the guys that have most impact to make. So study, use our tools, become experts, and then take those experiences into work life. And there you have a really good chance to make a difference. So basically what we do is we power the makers of a zero carbon future. And here you are. Okay, so let's then jump into the global construction industry and climate change. So Here we have this very messy graph from the UNEP emissions gap report, which shows the annual CO2 emissions in gigatons and the different scenarios with the associated emissions. So this is the latest report. So this is published at the end of last year. So the new report probably will follow at the end of this year. Unfortunately, they have been repeating the same topic over and over again. So here is where we are supposed to be if we want to align with the maximum of 1.5 degrees increase in the global climate, global temperature. And here is where we should be if we go for the less ambitious 2 degrees. And here we are at the moment. So this is our current stage. And this is about 57 gigatons of CO2 equivalent per year. I noticed that I left the old year here, but it's actually exactly the same. So there has been no difference whatsoever compared to the last year. Yeah, so here we are at the moment. And if these emissions continue on in this path, the emissions in 2030 with these current actions will be almost the same or even a bit higher. So here we have all these different scenarios that we can apply and we should apply. So if we start here from the current actions, we can see also these two different lines, so the orange line and the red line. So these represent the Paris Agreement scenarios. So these member states can give these kind of like nationally determined contributions or NDCs. So, and there's two kinds. There's the unconditional ones and the conditional ones. So the unconditional commitments are based on the agreements and national laws. So they're more likely than the conditional ones, but they also have a smaller impact. So hence here we have the orange line and the emission gap to 2 degrees and to 1.5 degrees is larger. So we need to make larger cuts. And then we also have the red line, which represents the conditional NDCs. So these are the kind that countries can make according to realized circumstances. So mostly the progress of other countries, and then those change the market, and then we can make more changes. So the impacts may be bigger, but the reliability is smaller. So the actual impacts is very hard to forecast, and the uncertainty is high. But it seems that we have to cut about or over 50% of our current emissions to be able to reach the 1.5 degree path by the year 2035. Or a bit smaller amount if we are going to, if these kind of like NDCs are going to be implemented. But still, it's a very big amount of carbon that needs to be cut. And how the building industry fits into this? Well, it's a very big contributor of emissions. So buildings are responsible for nearly 40% of global carbon emissions. And about 3/4 from this originates from operational emissions. So these are emissions that originate from the operational phase. So heating, cooling, electricity use, these kinds of things. And the remaining part is from materials and construction activities. So this is a huge amount of emissions that originates from buildings. And it has been forecasted that cities will double by 2060, so meaning that the floor area in cities will double. And this creates up to 200 gigatons of embodied carbon from construction materials only. And this means about 3 years of global carbon emissions, or building a New York City every month until the year 2060. So you can just imagine the quantities of concrete and steel that goes into those buildings. So for this reason, the World Green Building Council has stated that we need to be cutting embodied carbon now. So all construction should be operationally carbon neutral and create at least 40% less embodied carbon by 2030. So that is in the next 5 years. And it's obvious the construction industry needs to act fast, but is it possible to reach this goal? Well, it depends on the ambition of these actors in the construction industry. So yeah, things need to be happening, and by building less carbon intensive buildings, we can actually make a big difference quite soon. So as a clarification, again, about when we talk about embodied carbon, we mean all the greenhouse gases that are embedded in the materials. And these originate from the excavation of raw materials, processing of those into products, manufacturing emissions, transportation, use, and also end of life. So it kind of like incorporates the whole life cycle of the materials themselves. So if we dive a bit deeper into the emissions related to buildings and then see where the climate impacts mostly come from. So this example building is a typical Finnish apartment building with 4 floors and a cellar and the floor area of 3,000 square meters. And this is assessed with the Finnish assessment method that is compliant with the European EN 15978 standard, calculated over 50 years. The values are predominantly statistical averages from data that is gathered from projects that are assessed with OneClick LCA. So here we can see that the biggest impacts are embodied. So approximately 44% of the Sorry, I've lost my microphone. I hope you can still hear me. So approximately 44% of the building's life cycle emissions come from A1 to A3 emissions. So this means the extraction of raw materials, production of building products, and the product phase, basically. The next biggest emitter with a bit less than 40% of the whole life cycle emissions is B6. So here, this is the operational energy use. And the next biggest impacts come from P4, which is material replacement, construction site activities, and then transport, and also the end of life stage. And if we look at the issue on an annual basis, we can see that there is a very important emission peak at year 0 when the building is built. So this emission peak here, it includes all the materials manufacturing impacts as the high blue column, with the transportation to site and the construction site activities as smaller entities. So basically all of this is released before the building is even taken into use. So this is the area that we can influence by making smart choices and like smart design choices and smart procurement and comparing products and favoring green products and green production methods. So this is the thing that we can influence. So here with these green columns, you can see the operational energy throughout the building life cycle. So here we have until 60 years. A very small column here is the demolition and end of life of the building. And these pink ones are material replacements. But if we look at the energy a bit closer, so as we know, the energy sector is becoming greener. So it's decarbonizing slowly but surely. So the share of solar and wind is increasing a lot, and the share of fossil fuels is going down a bit. So the emissions from the energy sector are going to be smaller as time proceeds. So here we can see even more clearly how important it is to affect this emissions peak coming from materials like right now, because we can make a really big change if we do it now, and this will affect the situation as it is for a long time. So as I said, the materials will become the dominant source of CO2 emissions from the buildings in the future. So the operational emissions from energy, they still form about 50 to 70% of life cycle emissions globally. but this share may already be as small as 10% in passive houses, for example. And I'm located in Finland, and here it forms about 20 to 30% of the life cycle impacts of a building. So it varies a lot, but it's somewhere around maybe 50% if we look at, for example, Europe. So the average material emissions are exceeding operational ones already in some countries. So, for example, in Norway, practically all electricity is generated by renewables. So in these places, the material impacts are, of course, much higher than the operational ones. So embodied carbon, or taking embodied carbon into consideration, is simply the next level in energy efficiency and decarbonization that has been going on until since the 1970s. So we had the energy efficiency initiatives, the grid started decarbonizing, we had solar panels, wind farms being created, and then now we are here on our way to this kind of like holistic carbon management. So although the situation looks a bit dire, we're getting ourselves deeper into global warming, but there's also things happening. So there's an ever-increasing demand for carbon neutrality in the market, and the need to make changes also in the building sector is getting ever clearer. So in the sense, we are in a lucky situation, as LCAs and embodied carbon management is becoming a norm, and therefore required by businesses, regulation, and certifications. So being less bad no longer cuts in the market, but you actually have to make changes. So there are a lot of these certification schemes and different regulations that drive the life cycle impacts and the carbon footprint of construction materials. And these building LCAs, climate declarations, and material documentation is being required by customers, investors, and different nations as well. So that was our brief look into climate change and construction sector. And next we will talk about what exactly is life cycle assessment and how you can begin implementing it. So life cycle assessment is a holistic approach to the environmental impacts of a project. So it avoids shifting of burdens from one life cycle stage to another by addressing all the stages and provides the results in a way that makes it easier to implement desired changes to products, processes, and services. So this ensures that the means are timely. So that is to say that they take place early in the design process and at the specific moment. So how the assessment works, this is very much simplified, is that once we set the scope and the boundaries and assumptions, we get material information. We convert the inventory data into a set of potential environmental impacts, such as global warming potential or eutrophication potential. So when talking about greenhouse gases, embodied carbon or carbon footprint, we would get information about the different greenhouse gases. So for example, in this picture here, we have kilograms of methane, chlorofluorocarbons, nitrous oxides, and carbon dioxide, so all different greenhouse gases. And then we use a characterization factor, in this case, a characterization factor from the IPCC, which is applied to convert the life cycle inventory results to common unit of kilos of CO2 equivalent. And then we get the characterization of the impact category global warming potential, impact category indicator global warming potential in the impact category of climate change. So for example, for carbon dioxide, we would have a characterization factor of 1. So it corresponds to 1 kilo of carbon dioxide. But for example, methane, it would be 30. So 1 kilo of methane is 30 times as potent in the atmosphere as carbon dioxide. But when we put all those together, we get the global warming potential that we can report as a potential to cause these kinds of impacts in the nature. So the process can be implemented for materials or processes only, for different life cycle stages, or for the whole life cycle of a building. So Of course, this is all happening in the background. This is done by the LCA softwares by themselves. So you just need basic information on the materials and the quantities, and then you need to link it to the correct emission factor to be able to carry out the assessments. So the outputs from an LCA are impact category indicators, and each of these has an effect on a certain impact category. So the impacts are expressed as quantities of matter that have the potential to cause such impacts, but they do not represent the actual harm, which is the final impact, i.e. the endpoint. So for example, global warming potential represents the kilos of CO2 equivalents released, but has the potential to affect global warming, and the final impact might be the acceleration of polar melt, for example. So the indicators are usually named as potentials. So they have the potential to cause impacts, and the impact categories, on the other hand, are, for example, climate change and acidification. Yep, and there's some common impact category indicators. So we have global warming potential, so how much a product contributes to climate change. And when LCA concerns this impact category only, it is also called the carbon footprint. Then we have acidification potential, eutrophication, ozone depletion, photochemical ozone creation, and depletion of fossil resources. There's a lot more of these indicators, but these are maybe the most common ones. So they represent, for example, acidification potential, how much a product or process acidifies the environment, resulting in, for example, acid rain. Eutrophication is the flow of nutrients to ecosystems, resulting, for example, to algae growth, and so on. So if we then proceed to see how these impacts are calculated throughout the whole life cycle of a building, we must first get to grips with the standardized approach to life cycle assessment. So this infograph here explains the EN 15978, which is a European standard for sustainability of construction works, and it defines the LCA for buildings. So in this picture, we have different modules, and different modules are compiled under certain stages. So product stage is the A1, A3, and A1, A2, and A3. So it holds the raw material extraction, transport to manufacturing site, and then the manufacturing of the actual product. And when the product is finalized, we have reached the gate. So this is the cradle to gate assessment. We can transport the products onto the construction site, A5. And construction site operations basically contain everything that happen at the construction site when we assemble the building. And this also represents the boundary for upfront. So this is our practical completion. So if we have A1 to A5, it's called practical cradle to practical completion. When the building is finalized, we have the use stage. So that includes B1 to B5 for materials. So they contain the use of the building, maintenance of different parts, repair, replacements, this kind of plant refurbishment, and then that is the materials. And then we have the operational part as well in the use stage. So these include operational energy use and operational water use as well. And then when the building reaches end of life, we have C1, which is the demolition and deconstruction. C2, which is a transport of this construction and demolition waste into processing or disposal. So C4 is something that we're trying to avoid because C3 usually results in some benefits also from those materials that we can then see in the module D. So looking at the whole life cycle, we can also include benefits and loads beyond the system boundary. So these are kind of like incorporating these kind of circularity features then. So this is a more common representation of the building's life cycle stages according to EN 15978. So here you can see the same stages and modules as in the previous slide. And you can also see how the module D is here cut from the actual system boundaries by this dashed line. that reminds us that this is supplementary information only, so it's situated outside the actual system. So up until now, the regulations have basically been only considering this very small part of a building's life cycle, so operational energy. So all these different kind of like energy regulations that we've had for years now, they've considered only this small part. So if we're looking at other kinds of assessment types, so this is the cradle to gate, so A1 to A3, and this only considers the initial material impacts of a product. And if we include the transportation and construction impacts, we have cradle to practical completion, as we saw also in the other picture. When we also consider the end of life impacts and include the operational part, we have the cradle to grave assessment. So this is usually the most typical approach for building LCA. But if we include building module D, we have the cradle-to-cradle approach, and this is also, as mentioned, where the circularity comes in. So it kind of like holds these, for example, benefits. If we have a wooden material that has been in a building, but when the building has been deconstructed, the wood goes into a plant, is incinerated, and the energy is captured, and that energy is fed into the grid, where it basically substitutes fossil fuels, for example. And this way we can also reduce the emissions from that grid by including these kind of waste materials, and then that in turn brings benefits. And here also, if we lose the operational part, we have an embodied carbon assessment. So this includes only the material emissions, basically. So what is the appropriate time to conduct an LCA assessment? And the sooner, the better is basically the answer. So the decarbonization potential tends to diminish quite drastically after each project stage, so it can even halve. So when we are at the strategy phase, so we are drawing up plans, thinking about the need for our building and how we can fulfill that need, we can make the most impact at that stage. But then when we have already our drawings are ready, we are starting to fulfill our processes, we have already lost a half of that potential to make these changes. And then when we move on further and further at the end, when the building has been is being built, we only have something like 10% left of our decarbonization potential. At this stage, it's mostly like comparison of different products or different manufacturers, and at that time, it's very difficult to make big changes. And here is another picture. So changing the project direction becomes increasingly difficult and costly when the project progresses. So decarbonization potential is limited, as well as the ability to influence specifications, because the cost of change increases as these project phases also move forward. Then about data. So we talked about like the data behind LCA. So we talked about these kind of like characterization factors and emission factors and these kinds of things. But if we go back to basics, how is the building embodied carbon calculated? So it's very straightforward. It's a multiplication of the quantity of materials and the impact of the material across the life cycle. And then all of these parts are summed together to account for the whole building impact on global warming potential, for example, if we are making a carbon assessment. So, for example, you can imagine that you have 100 kilos of bricks and you wish to know their impact in our building. So first, we need to know the emission factor for a unit of bricks. So it might be kilos, for example. So for 1 kilo of bricks, we have an emission factor of this. And then we just multiply it with 10. And then we get the impact for 10 kilos of bricks. But how do we know what emission factor to use? So for this, we of course need environmental data. And here we come to the term EPD. So EPD stands for an environmental product declaration, and this is a document that holds a life cycle assessment for a material, so for a single product, basically. EPDs are externally verified and standardized description of the environmental profile of any product or material over its life cycle. So it helps to transparently communicate the product's environmental impact and provides a summary of cradle-to-grave emissions. EPDs are standardized, so they are type 3 environmental labels, and they are based on the international ISO and European EN standards as well. So they are considered very reliable information. And why are EPDs useful? Because they are objective. So they are based on internationally accepted standards and validated LCA methods that are defined in these standards. They are credible and neutral. So EPDs are critically reviewed, approved, and maintained by independent third-party verifiers. They do not make environmental preference claims. So because a product has an EPD doesn't automatically mean that the product is environmentally friendly, but it does mean that it is valid data. EPDs are also open, so they're applicable to a wide range of products and services, and they can be easily accessed via the internet. So there's basically, this is public information. They are environmental impact oriented. So again, while the EPD doesn't really mean that the product is necessarily good or bad for the environment, it does assess the potential environmental impacts, and having that information is extremely useful, of course, when we are considering LCAs. EPDs are also instructive, so they give general information as well as explain terms, definitions, and LCA concepts, and they also help to interpret that information. So in a nutshell, EPDs are based on real data. There is no forecasting. So that means that you can only use either very specifically defined scenarios, but mostly you have to use actual process data to create EPDs. They can represent either one product and one factory. They can represent many products from one factory or similar products from many factories. So there's different types of EPDs for all these situations. They're most often valid for 5 years. There's also several kinds of EPDs that represent different scopes. However, with the new product standard that we are using at the moment in Europe, it mandates the use of cradle to gate with options. So preferably this cradle to gate. So we have A1 to A3, but then also we have to add these end-of-life modules to account also for those modules. Yeah, and they offer also knowledge on the product's environmental performance. And it is worth noting, of course, that only similar products that are calculated with same methods can be compared. So there's also different standards in different areas of the world. And also these kind of like EPDs that follow different standards cannot be compared. And also EPDs actually, like products, can only be compared if in the scale of the whole building. So a window cannot really be compared to another window unless these both windows are being compared in the same use type on the scale of a building. So here's just an example what the real EPD looks like. So here we have the standards. So this says that this environmental product declaration is made in accordance with ISO 14025 and EN 15804 plus A2. So this is means that it's valid information based on actual EPD standards. Here we have information on the product, so the brand name, if there's some specification for that, and also, very importantly, the date of publication, which defines the validity. And here also we have this, for simplicity, also mentioned the best before date, basically, and also the scope for this EPD, which is pretty good. And here we have information on the program operator, so the body that actually like produces the EPD and then publishes it and then maintains it in the database. And then when we go forward in the EPD, we can see more information on the program operator. So this is the international EPD system. Where is the website and where they're located, so on. About the PCR, so product category rules, and what were they made according to, who was the third-party verifier, and then we have information about the product. So product description, description of use, and also here, for example, this EPD is an average of 3 glass production sites in Europe. So this is important knowledge so you can reliably use this EPD for your own assessment. And then we have more data about the type of EPD. So for example, this is cradle to grave with module D and what stages are included. So this is a very comprehensive EPD. Functional unit, so 1 square meter of this glass. So for example, if you're comparing to some other product that is declared for kilos, for example, it's not possible to do it directly, but you have to do some unit conversions first. System boundaries, reference service life. This is important for the calculation of replacements in a whole life cycle analysis, cutoff rules, allocations, and so on. And then once we've read through all that information about the product, about the EPD, we find the environmental impacts. So as this was made according to EN 15804 plus A2, we have 4 different climate change. So we have the total, fossil, biogenic, and land use change, all declared here for different stages. So for product stage, construction stage, use stage, some of these are also separated into modules, end of life, and so on. Product stage A1 to A3 is usually declared as a whole instead of dividing it into different modules. And then we have all these different indicators here as well. Yeah. But when you're using OneClick LCA, this information is, of course, directly embedded into the data points. So you can just choose the appropriate one and you will get your impacts calculated automatically. A bit about the standards. So I will be talking and you will be also hearing these kind of standards quite often when we are talking about LCA. And that is because LCA is a standardized process. So that's important to know. And following these standards is very important for comparability, of course. So the cornerstone standards for LCA are the ISO standards. So we have 14040 and ISO 14044. So these are fundamental for LCA. They are used also for other things than just building LCA. So they are used in all industries and in all professional contexts. But then we have also construction work specific standards. So EN 15978, as I mentioned. So this is for construction projects, buildings specifically. And then there are also other ISO standards that are used outside Europe. Environmental product declaration standards, we have the ISO 1425. So this is the cornerstone standard for all kinds of EPDs. And EN 15804, which is for the EPD data. So that kind of like is the core product rules for building products specifically. And then there's also an ISO standard that is used outside Europe. So all these rating systems and methods that we see here, they are either EN or ISO based or both. So they are all based into these cornerstone standards, and then they have their own different ones. So for example, we have European levels framework or RE 2020 or the Finnish low carbon assessment. They are all based in EN 15978, which makes comparing the results at least partly okay in the context of Europe. So the EN 15978 sets the rules for building LCA. So all schemes and regulations in Europe follow this standard. Exceptions may take place, especially in which life cycle stages and modules are assessed. But European Union has existing and tightening regulations regarding this as well. So for example, we have the taxonomy requirements for sustainable financing. We have the new Energy Performance of Buildings Directive that is being implemented around EU. And many countries also have their own regulation related to building sustainability. But the aim within the EU is to harmonize all of these. And the EPPD will be introducing new assessment rules basically for new buildings that need to be reported within the EU. And then there's just a few examples about the national regulation. So RE 2020 in France, for example, BR 18 and BR 25 in Denmark. And then in Finland, we have the building low carbon assessment method as well. So they're all kind of similar, but they have their own little differences that make them, well, they're not directly comparable, let's say. And just a quick overview of what data to use for information. So EPDs versus generics. So if you are in a situation where the building product is known, you should always go for the product-specific EPD if that exists. If it doesn't, you can go for a generic EPD, so a sector EPD or an industry average EPD, or then you can go for a technically or regionally similar product EPD or generic data that complies with standards. So for example, OneClick LCA creates these kind of like generic data points that can be easily used as average values. But if the product is not known, you should first go for product category EPD and then generic information that complies with standards. And as the last step, technically or regionally similar product EPD or generic data that complies with standards. And it's usually not recommended to use any other data than these EN or ISO standard-based data. Okay, but then we've concluded our introduction to the world of LCA. So what kind of things you need to know before you begin, what kind of data you can use, and what are the main standards regulating the process. So we can now continue with the software demo. And before actually that, we will check how to create your account and also see what kind of tools we have included for you. So we've included the Levels Lifecycle Assessment, which is a full lifecycle assessment tool for building LCA that aligns with EN 15978. There's two tools. So there's Levels LCA according to EN 15804 plus A1, and then there's Levels LCA with EN 15804 plus A2. I just realized that I forgot to add the carbon tool, which is also a good thing to add, because if you want to calculate only the carbon footprint of your building, then you can use that tool as well. These two have the full set of LCA indicators or impact categories as result. The difference between these two is that this is based on the old standard and this is based on the new standard. So when you're using plus A1 data, you are risking of having a lot of expired data. But then when you're using plus A2 data, you're risking of not having that much data. So companies are producing these kind of plus A2 EPDs continuously. But there's also some data caps that then might happen if you only use plus A2 data. Unfortunately, it's not possible to mix these two, so you have to use either one. I suggest you go for the newer one, of course. But if you think that you can't find enough information there, then you can, of course, use the plus A1 tool as well. We've also included the Carbon Designer 3D, as mentioned, so we'll go through that in the next session. And also circularity tool. So this is an interesting one. So you can actually use it on the side of your LCA, and then it will update as you feed in data to your LCA tool. The circularity tool will be calculating simultaneously. And in there, you can also make these different changes regarding the reuse, recyclability, or these kinds of things. But we can take a look at that. There's also a link to the help center behind all of these. So make sure to go and check it out. Help Center is very good source of information for all things that is related to OneClick LCA. So if you have a problem, I'm pretty sure that you will find an answer to that issue in the Help Center. Yeah, so about the Levels tool, so you can find more information on the Levels framework on the course page, where I added links to the Levels site and also to the manuals in case you want to study this framework a bit more closely. But here's just an overview of what it contains. So it's this kind of like a wider tool that can be used to assess these different macro objectives. So we have, for example, here the greenhouse gas emissions along the building's life cycle, but then we have also other macro objectives, so resource efficiency, efficient use of water, healthy and comfortable spaces. So this is something that you might want to take a look at considering your contest tasks. So you might want to include some of these other objectives into your into the task as well, if you want to. Yeah, so these macro objectives are characterized by indicators. So for example, here under macro objective 1, we have indicator 1.2, which is the life cycle global warming potential. And the Levels tool follows this indicator. So before you register your account, or before you can get started, you need to register and activate your account. So what you need to do is click here, of course, and then you can select login from upper right corner, and then register, fill in your information, activate your username. So if you can actually use the same username and password as for the Academy. So when you created your account to register for the Academy, you can use the same credentials for OneClick app as well. If you need to activate it, you will get this kind of like email. Check your spam; it usually goes there. And then if there is a link to activate, you just click that, and that's it. There is the Authenticator app, unfortunately, that you need to use to enter. Then, once you have created your username or your profile, you can start creating a building project. So here is just a screenshot of how it looks like, but it's very important that you follow the steps that are outlined here and also on the course page, because you need to enter the license key that is given. It is given in the course page as well, and you need to press activate. Otherwise, you will not be able to use the tools that we have included. Then you can start creating your project, and within the project, you can start creating the different designs. So we will take a look. So I hope that you will now forget about the registration and the license keys and everything for a moment, because I will now proceed to the software and we will go through things rather quick paced. So I'm not expecting anyone to actually do the things simultaneously. So just listen, watch, and then you can return to the recording the next day and then just take it from there. Let's see. I need to, nope. Here. Okay, so once you have registered and created your account and everything, activated it and so on, you will be able to access your main page. So this is the page where all your different projects will appear. Of course, there will be none for you if you haven't created any. There's a lot for me because I have been creating too many. It's possible to search through the projects and also sort with the date of creation. Here you will also have access to your own user account. So if you click here, you will be able to, for example, change the language. So it's English by default, but you can also change this from your user account here. So when you create a building, you need to add a building first. So click here, add, and then building. Just a second. I want to organize my screens a little bit. Okay, and let's hope that it answers. It's behaving a bit slow. Yes. So now we have reached the step 1 of creating a new project. So this is the important part that I was talking about. You need to link the project to a license. Since you don't have a license, but you have a license key, you click here. A field appears, and then you can just feed in the license key. And it's case sensitive, so be sure to check that it's correct. You might want to just copy paste it from the course page. Yep, so now it has found the license. Just click OK, and you will get this here. If you don't, you might want to check that you have written everything correctly. Otherwise, you probably won't be able to access. So we have some mandatory parts here. Of course, the name. So I will just write a name for my building. What kind of building it is. So for your apartment building, choose apartment building. So this is something that helps you with the benchmarking. When you have reached some results, you will be able to compare it to other projects created by other users. So for example, apartment buildings within a certain region, and you will see how your building is faring. For the renovation, I suggest you choose the one that fits best. So it could be, what do we have here? For example, it could be, well, it was some kind of yachting club. So I don't know, something from here anyway. So it could be, for example, what could it be? Well, choose the most suitable one from the list. There's a lot of this. It could be, for example, a cultural building, I think, for the use that has been defined. So for address, you need to add the country. If you have a closer location, of course, you can do that. I will just add an address as Serbia. It could be Belgrade, for example, and then the country, of course, has to be Serbia as well. Then we can jump into the next page. So we have optional information. If you already have information of cross floor area, number of floors, or these kinds of things, you can add them. But as it says, it's optional, so you don't have to. Then you can just click next, and we will be coming to the first design. It is very slow today. Let's see, I'm on my mobile net, so I'll just move closer. If I can get better reception from here. Let's see, I think my connection looks okay, but for some reason it's very slow. Well, let's just give it a moment. Okay, let's load it again. If it's not working properly. Oh, okay. Sorry, just threw me out. Let's try again. Activate. Yeah, sorry about this. There's always these technical issues related to demonstrations that are always not that fun. Well, let's. Can we find Belgrade? Yep. And then try again and jump over this part. Yes, worked. Okay. So this is our third step. So creating your first design. So we have these helpful little hands here. It says create at least one design to start calculations and click started. So here we have the available tools. So I will just pick this plus A2 version, as I said, because it's the newer one, the most recent one. It has the most recent data. And also click the building circularity box here. So you can add those. And then you will be able to create your first design. So let's, for example, name this as baseline. You have the opportunity to put additional information, the stage of construction. So these are the REPA stages. You can choose whichever you feel like. Of course, it's good to start from the concept design when you are in the early stages. If you choose another stage, it will just appear in kind of like the proper order in the design or in the project page. So this is all fine. Let's just click next. And then it asks us to review and adjust LCA parameters. So it's possible to use default LCA parameters, but let's review them. So the parameters are something that kind of like they fill out the default, some parts of the LCA calculation. So we have parameters that have to do with service life, transportation, material manufacturing, end of life, and site wastage as well. So the service life, of course, is important because it defines how often a product is changed throughout the building life cycle. Since we are using a levels tool, we also have a levels service life. So this is something that is defined in the levels guidance. So I advise you to use that one. There's also different ones. So the technical same for same material is basically if you have a similar material, for example, a window, or you have an external door, or you have a concrete element, it doesn't matter what kind of product it is, as long as it is same material. And in this case, it will always have the same kind of service life. So a window will have the same service life as another window, for example. If it's commercial service life, it means that some of the surfaces will wear faster. So, for example, floor finishes will have to be replaced more often. So this is something that would apply, for example, to commercial buildings. Product specific means that if you have a certain database that you need to use, it usually derives the product specific service lives through that database. So there might be some differences between different countries. For example, for the Finnish method, we would use the product specific service life that is tied to the data that we use here. There's a lot of different ones for different assessment methods. But let's use the levels one here. Then we have the transportation scenarios for materials. So transportation distances are always editable, and they should be representing the distance from the manufacturing plant to the construction site. But since it's not always known, and especially in the early phases, when we don't have that exact information, we can use these average distances. So here we have by default the European distance, and that means that for example, concrete elements, a typical average transportation distance in Europe is used, and also the transportation mode. So what kind of vehicles are used to transport that. Localization method, it is by default the recommended newest one, so version 2.1. So what this does, it adjusts the material manufacturing impacts to that country that you're in. So for example, we are in Serbia. It doesn't have that much EPDs published, but if we know that a certain material is being produced in Serbia, we might use an EPD from another producer from a neighboring country, and then just localize those impacts to Serbia. So they will kind of like, it will be a bit more accurate representation of the impacts of that material if it is actually like produced in that country. And this is just means the material manufacturing localization target. So basically the electricity grid emission profile. The end-of-life calculation method, we can choose different ones, market scenarios or EPD end-of-life scenario. Market scenario is always advised because it represents the actual market situation in the country. If it's an EPD end-of-life scenario, it might differ. So for example, if we are using a German EPD for Serbia, the end-of-life options for a certain material might be different. So I always advise to use the market scenarios because it represents the actual situation better. Then if we have some end-of-life energy recovery that substitutes fossil fuels in the grid, then we can use these kind of like profiles here. They are by default what they are, and I think that they should be left as they are unless you have a very good reason to change them. And then there's also site wastage values. So this is just the typical quantity, a typical percentage of wastage that happens in the construction site for different materials. So for wood, it might be certain percents, and for concrete, it might be certain percents. So it's always the same. And we can use global here, and it's always editable if we happen to have more information about the construction site impacts. So now that these are reviewed, here's also a very helpful link that directs to the help center. So if you want to know a bit more about what these parameters mean, how they are calculated, go and check this out. And also it's a good practice to do this before you start calculating anything, because if you change the parameters at some point during the calculation, all your project information will be recalculated, so it might change something. Okay, so here now on our project page, we have the different calculation tools. We have one design, and we have options to input data. So the building circularity, as mentioned, it calculates as you fill the actual LCA calculation tool. So we don't actually need to touch it now. We can check it after we have added some materials and see what it looks like. So here, when we click open this little arrow, we get this kind of table. So we can jump directly to results. Of course, we don't have any results yet because we don't have data. And we have different query pages to input material data or energy data or construction site data and so on. It's also possible to import data from external sources. So for example, from Excel, we can also import IFC files and these kinds of things. So you feel free to test those out and also check out the Help Center articles related to this. I'm not going to take you through it now because it's a bit time consuming. So we'll just check the manual material input. So let's click on the building materials. Okay, so we have reached the actual calculation tool, and this is the building material tab. So this is where we are inputting the material information for our project. There's all these different tabs. So we have one for project description, energy consumption, water consumption, construction site operation, emissions and removals, maintenance, calculation period, and building area. The mandatory parts are marked with these red arrows. So these are something that you always need to define. Things like water consumption is not mandatory, so you don't have to fill that out if you don't have the information for that. But the scope or the boundaries for this system in this levels tool, it is a whole life cycle assessment. So it gives you the opportunity to fill out every single life cycle stage defined by the levels framework. Okay, so the building material query is divided into sections. So we have foundations and substructure, vertical structures, horizontal structures, other structures, external areas, and building technology. They don't define your calculation, but they do define how the results are presented. So you can put things in places where they don't belong if you, for some reason, want to. But for like visualization and organization of the results, I do recommend to put foundation materials under foundations, external walls under external walls, and so on. We also have different material filters here. So these are here to help you find materials. So let's start by putting some concrete into our building. So if I just type in concrete, it will give me thousands of matches, like literally thousands. I can click here to see them all, but as you can see, this might be a bit too well, it's a not very accurate way of adding data here. So it gives me a lot of different countries, a lot of different data points. And I can either write a better description or I can use a material filter here. So let's apply one for example, do we want precast concrete or, oops, we want to have ready-mix concrete, for example, and we can even define it further if we know the grade of the concrete. So for example, if we want to have something for foundations, for example, we can just click that here. We can also apply a country filter. So if we want to look for generic resources or EPDs in Serbia or something else, a neighboring country, for example, we can choose a data source from here. So what kind of EPDs do we want? So for example, do we want to have EPD hub EPDs only? Do we want to have OneClick LCA generics only or something else? And we can also choose the kind of data that we're looking for. Is it generic data, manufacturer-specific data, even plant-specific data, or project EPDs or private EPDs? Private EPDs are something that you need to add yourself, and I don't recommend going there. So we will just use what we have here in the database. Upstream, well, this is a bit too detailed, so you can even choose what kind of like LCI database the data is based on. The CO2 or the carbon clouds, it's really good. So you can actually choose what kind of data you're looking for. So is it very low, average, very high, or something from, something in the middle? You can even filter by units, standards. What else? We have also different data filters and even some purpose filters, which I'm not going to go through. But we now restricted the database to ready-mix concrete for foundations. So I can just, again, type my concrete here. Whoops, there's nothing. Let's see. So I can just click this open as well. And I will get a lot of different options to choose from. So these are OneClick LCA generics for Serbia. So when you are doing an assessment in the early stage, I recommend to choose average data. So this kind of like generic data for a certain location is a quite good place to start. So when you're looking for average performing product, you might want to check the carbon clouds. So it would be something between the yellowish or orange. So these are both quite good options, and they represent the kind of like average performing product within their own product group. So I will, for example, choose one concrete from here, and we can add, for example, 100 cubic meters, and then hit save. And then we might want to add, for example, oops, let's take that one out. And put some rebar in there as well. And let's also go for something like that. Okay, so when you add a data point, you will get this kind of green question mark here. And when you click it, you will be able to open the data card. So this will tell you the full name of the data point. You can add it as your favorite. You can copy the name to use somewhere else. And it will also give you a lot of information about the data. So for example, this is general information for this product. The country is Serbia, manufacturer, OneClick LCA. That just means that the data point has been created by OneClick LCA, and also the material type. And then EPD program, again, OneClick LCA, because it's created by us. The year, of course, always use as recent data as possible. And also what product category rules it aligns with. Then we have a description of the materials, for example, what kind of mix it is. So we have CEM3 type cement and 55% GGPS and so on. Some technical characteristics such as the density, environmental profile. So here we can also click to see the full ranking. So we can see our concrete compared to other concretes. So this is the line that represents our concrete, and we can see neighboring countries and then all different concretes in all countries in the database. So we can just see where we are compared to others. Yeah, and here you can also see like what is the location between like within all the different ones. Then we have some default scenarios and assumptions, and these also relate to the parameters. So what is the transportation distance? We have 60 kilometers by concrete mixer truck, wastage on site, and these kinds of things. So these were defined by the parameters. So here we have the transport. So if you remember, we chose the European transport distances. It also defines this material dependent transportation method. If you have, for example, transportation via highway and then urban transportation, you might want to add the leg 2, or if you have, for example, transportation with 2 different methods, or transportation from, for example, storage site to the construction site, then you might also want to use the leg 2. For foundations, the service life is always permanent. For others, you can always edit this. And here we have, because this is a generic data point that has been localized to Serbia, we have the localization information here. For all data, it's possible to add this repair. Of course, for foundations, it's probably not necessary, but you can add it as a percentage from A1 to A2, for example. So here we have an example. If one window in 10 breaks every 5 years, appropriate annual repair is 2%. So this is just something that relies on assumptions. And these kinds of assumptions is, of course, something that you need to define yourself and also be able to report if required. Wastage. So we have the global wastage. So this just means that for ready-mix concrete, we are expecting 4% wastage at the site. So this represents the A5 impacts for this material. And you can change this if you know better. End-of-life process. So we have some options for different materials. So for example, landfilling of concrete. So if you remember, again, we chose the market scenario for end of life. So for Serbia, this might be landfilling for concrete as blocks. In other countries, it might be concrete crushed to aggregate. But this defines your emissions in the C3, C4 modules and also some of the module D inputs. If you have a reused material, you might want to click this. And if it's locally reused, which means that it's already on the site, you can click this and it makes some of the impacts go away. Here is also a possibility to change the units. So not all data points have different units, but if the EPD or the generic data point contains this kind of information for different units, it has these conversion factors, for example, embedded in the data point, it's possible also to change these. So for example, for this one, we might change the cubic meters into kilos and it will automatically calculate. But we want to keep it as cubic meters. When you are working with others, do leave comments. So if you make some changes, always comment here. This is a good practice too, and also for other reasons. So when you're bringing data, what kind of building part does this material contribute to, or these kinds of things. So all sorts of information can go into the comment. And so we have the sections, foundations and substructure for this one in particular, but you can also define the building part. So this is the levels classification system. So it's also possible to define it a bit more if you want, or keep it very high level if you want. So you can only divide it into shell and core, or you can divide it into more granular data. Yep. So, yeah. And then we could, for example, take a look at the constructions. So I will add some insulation, for example, here. Let's take, for example, stone wool insulation from Romania. Might be applicable here. Let's create, for example, this kind of external wall structure. So it is possible to, where's my, let's see. Yeah, so when you are creating or bringing in data manually, or if you are even importing it from somewhere, you can utilize these kind of constructions. So a construction is a thing that contains resources beneath it. And then when you change the quantity for a construction, everything inside it will also be calculated. So I'll just show a quick way of creating a construction. Very simple. So let's see, we have, for example, concrete wall element. Yeah, and we will, stones. well, let's ignore the quantities here. I'll just 300 kilos, for example, stone wool insulation, we have one and one. So here, when you go through the material filters, you can also see them. So these are ready-made constructions. So they consist usually of OneClick LCA generics, but they might also contain other kind of average information. So you can find, for example, foundation constructions or, for example, external wall constructions. So we could actually add an external wall here, and let's see what kind of information we have. So we have all these different ones. Let's go, for example, for in situ concrete wall assembly and add that. So you can see we have this kind of little wall sign here. So when we click the plus, we can see all the resources that are contained within that construction. So how this works is that if we, for example, add 100 square meters of this, it will automatically populate these others. And then it just makes it much quicker and simpler to kind of handle these kind of bigger elements. So let's see if we just save in the middle. And you can also see actually that here in the construction, it says the transport and service life and everything like that are data by constituent, which means that when you open it, each of these constituents or these resource rows will have their own information related to that particular parameter. So you can use these ready-made ones, or you can create your own ones. So for example, here I have just a simple wall structure with precast concrete, some stone wool insulation and impact-resistant gypsum. I can just paint over them so they turn green, and then I can create a group. And here I added just like 1 square meter of insulation, 1 square meter of plasterboard, and then just, to represent the 1 square meter of concrete element, 300 kilos for that. So this could be, for example, named like this, and then the reference quantity in this case would be square meters. I can assign it as an external wall construction, add a description, and then also here check that the building part is correct. And then I can create this group for this project. So you and, oops, why didn't it move? Okay, they didn't go in for some reason, but I can also just drag them here. So either paint and click create a group, or just create a group and then just drag these things here. And if I now save it, it will appear in this project as a construction for an external wall. And other people working on the same project can also utilize that construction. So here I have my test construction. And if I want to change it, you can see that the quantities are populated. If you don't want to create your own, but you want to use these ready-made constructions, you can just see what it contains. And then, for example, here we have, I don't know, generic stone wool that we want to change into a Saint-Gobain stone wool. So we can just go to change. And here we have all these different options. So we can unbundle the construction. And this means that the construction is broken into the constituent pieces. And we can just go, for example, for this stone wool, we can have to click save in the middle. But then once we have saved, we can go back to the change function and then replace. And then we can replace this, for example, with, again, this kind of like isover stone wool, for example. And then when we save, it will update our resource. So here, our stone wool insulation was replaced with another one. And then we could just basically regroup it again and then go from there. Okay, for some reason this doesn't work. We can just, again, drag these in and then use that. Good. Yeah. And yeah, just like as I mentioned, put things into the right places, building technology systems here. If you have PVs, for example, or an HVAC system, it should go under here. And then once you have filled out the data that you want to fill in, you can continue further on. So if you have the energy modeling made, you have the energy consumption of your building on an annual basis, this is where it goes. So you go to the energy consumption tab. When it wants to upload, let's see. So energy consumption, water consumption, emissions and removals, and maintenance, they are all related to B stage, so the in-use phase of the building. So they are all annual queries. So we will need to input the annual energy consumption here, the annual water consumption here, the annual emissions related to, for example, those HVAC equipment. So if we have, I don't know, an AC system, for example, that utilizes a refrigerant, the refrigerants tend to have a certain leakage rate during the use and also at end of life. So this is something you need to put into the emissions and removals tab. And the maintenance is usually a scenario-based thing. So you can either input energy flows, so like electricity or water or some kind of fuels that are related to maintenance activities, but there's also the possibility to input like scenarios. Okay, so now we are in the energy consumption tab. So just click the arrow and you will get different electricity profiles. So let's take the first one. So as mentioned, this is the annual consumption. You can add comments, choose a different profile, but I always advise to use the most recent one. And you can also assign different usage types to it. If you don't want to, you can use the overall. It doesn't affect the calculation. It's just there to help you sort things out. It's possible to add fuels. So if there's stationary units or if there's district heat, you can also add that here. So for example, we have a couple of different profiles for that. Fuels used in nearby or own heat suppliers. So let's assume that our building only uses electricity. It has PVs, so we also export part of the electricity. So we can also add a data point for that. So this represents the D module benefits outside the system boundaries. So we are exporting electricity from our building to outside the system. So if you have electricity that is produced by PVs but is used in the building, you can just deduct it from here. So for example, we can say PVs generate 5,000 kilowatt hours per year. So we could just put like, I don't know, 95,000 kilowatt hours here. And then if we are exporting part, we can just put that here. And this will be reflected in our D module. Yeah, as mentioned, the water consumption is an annual query for water. It's just important to note that you add actual water, but also the wastewater. So which I can't see here. Let's see, conventionally treated. I should have wastewater here as well. Okay. I need to check that. Usually you need to also add the wastewater to reflect the processing of that. Construction site operations is something that you don't need to know. So if you have, of course, like specific information on electricity, fuel, machine hours that that happen when the building is being built, but you can also use construction site scenarios. So this is an easy way to account for those impacts. So you would just choose the appropriate scenario from here. So, for example, I would choose the European electricity mix, maybe for, it might be temperate climate, maybe. So we can use that one. And then you just add the gross floor area of your building here, and it calculates accordingly. Deconstruction is always handled by a scenario. So you just pick the correct frame type from here, and that is calculated from there. Emissions and removals, as I mentioned, so these are related to the refrigerant leakages, but also carbonization of cementitious materials, which also has a lot of like different scenarios here. But if you don't know this, I would leave it out because it's not relevant usually. For refrigerants, it's just important to know which kind of refrigerant you are using, and then you can just add the quantity, and then the service life and the annual leakage rate and the end of life leakage rate here. Maintenance, as mentioned, you can input actual data, but I suspect that you probably won't have that. So you can also add a scenario, and these are usually related to the floor materials. So what kind of maintenance does some kind of floor require? Calculation period is important. So if your building is less than 50 years, if the service period is expected to be less than 50 years, you should write it here. If it's longer than 50 years, it still needs to be calculated for 50 years because this is the actual calculation period defined by the levels framework. So always put 50 years here. You can, of course, make different designs for different service lives if you are interested to know what kind of impact that would have. And then we need to add our floor area for the building. It's possible to change or have these other things as well, so such as number of users, use days, or these kinds of things. But the gross internal floor area always needs to be included there. And then you can just go to the results. So I will talk about the results a bit more in Thursday's session. But here you can see, for example, the Carbon Heroes benchmark. So here the building type comes as important. So it kind of uses it to benchmark your project against others in this region or other regions. So you can choose it from here. This, of course, is not correct because we have 2 materials in our project. We have the full set of environmental indicators here, and they are declared for different life cycle stages and modules. If you want to change the formatting, you can choose decimal numbers from here under more actions. For me, at least, it makes it easier to read. And here you can also get more information for the different, for the granularity of the data if you want to have that. Details gives you more information about the calculation basis, so if you're interested in that. Then we have also the completeness and plausibility checker, which of course it comes as important in later stages when you have more data in your project or in your design. So you can go and check, if it's flagged, there's something wrong usually. So for example, for me, I don't have any horizontal materials, so of course this is flagged. But for example, I added some gypsum and that makes it already okay. Most contributing materials is a good way to check what has the most impacts in your design. And you can also use this to show sustainable alternatives. And then we have all these different graphs that you can check, and they will kind of like divide your information or the data a bit more easily visualized. And you can also see all your data sources from here and also download the EPDs if there are any. But yeah, as mentioned, let's take a look at these results a bit more closer in Thursday's session. So this was just a quick demo of how the tool works and what we have there. But now I have a couple of minutes, so I will show you the building circularity. So as you can see, it has populated some of the fields. So we have information here, even though we haven't put anything in. So we were just working with this tool, and it has automatically transferred the information here. So let's see the building circularity. Yeah, so it looks exactly the same if you look at it quickly. So it has the same sections, it has the same materials that we have added, the same quantities and comments and so on. But it also has other things here. So for example, for our ready-mix concrete, let's see, we have this data card, and it shows that we have some recycled content in the actual data point. So this is the share of recycled material in the product by mass. Yeah, so because GGBS is quite light, it only shows 5% of the mass being recycled. But then reinforcement steel is made out of steel entirely, of course, 60% of it is recycled, so then it shows here as 60%. Renewable, if there were renewable materials here, it would show here. If the part of it was reduced, it would show here. Then we have the wastage, end of life process A5, so you can actually like divide the data more closely. So what is done to the waste that is generated on the construction site, and then also like what is the process for this end of life. So here we have the landfilling, but then also like what kind of end of life process it is. So if we're landfilling, it will be actually it should be disposal here in this case. And this is also, I think it should be 0 and 100 actually. And then you can also assign these different structural roles that help you assess the design for adaptability and design for disassembly that you can see in the results soon enough. And then also you can add a tab here, like click this if you think that the material is hazardous, and this will also affect your results. We have a similar kind of project description as we do in the LCA calculation tool. Doesn't really have any information. Some circularity score weighing factors, so how the circularity is actually calculated. So material recovered represents the use of the circular materials in the project, so what is already in the products. And materials returned represents the end of life circular handling of materials. So we have different options here. So virgin materials, of course, the weighing factor is 0, reduced is 1. And here, for example, for disposal at end of life, we get the 0, but then reuse gets a 1 as a weighing factor. Calculation period is identical to the LCA tool. And here we just get this kind of like circularity score as the result. So of course we have very little materials. It's not complete at all, but from the materials that we have added, 5.5 represents recycled materials within the products. And then the materials returned. So what kind of things are done at end of life, and disposal now contributes most of it. So our circularity score is not very good. Here we can also get more information per result category. So we have construction materials, construction site, key material groups here. So this is for EU taxonomy reporting. We can also get this for different categories. And also here we have the energy recoveries, disposal of hazardous materials, and all these different things. And then the design for disassembly, value for reversibility. And this depends on the different choices that we have made in the material query page. Yeah, and also different kinds of graphs to represent our results. Okay, but that was it about the software. So let's put this back here and present. Okay. Yeah, so as I mentioned, there is a homework, but this is totally optional, so you don't have to do it unless you want to. So I just attached some of the reading materials here. So the emissions gap report, the latest one, and then the embodied carbon review that has been made by OneClick LCA a couple of years ago, which is still very valid read. And also, I want you to familiarize yourself with the OneClick LCA software. So again, the sooner you start with this software, the easier it is to implement these embodied carbon principles into your contest task. Demo that was done already. So yeah, and also join the discussion. So you can just, when you get these materials, you can just click here to access the OneClick LCA community. So also if you have some questions you want to ask there, feel free to do it. And now, yeah, so if you have some questions, you can write them in the chat and I can try to answer. Next session on Thursday, we'll discuss how to get started with the LCA at very early stages. So when you may not have any information to actually put into your project. So how can you get started already before that? And this will be done with the CD3D tool. And then also we will go through how to create a project for a renovation. If there are no questions, I will just thank everyone. Oh, there is a hand raised, but unfortunately you are not able to turn on your microphone. So if you would be able to write your question in the chat, that would be awesome. Because unfortunately, it's not possible for me to give you permission to speak out loud. So if you can just find the chat from the bottom. If you don't want to write your question, you can also do it later in the community page. And also, Timo actually left a note here, but he sent it only to the hosts. So I will actually write it here as well in the actual chat. So he told everyone to go to the FAQ that's available on the website as well. So if you have any questions related to the contest, you can feel free to go there. And yeah, so I can't see any questions appearing. So I think I will just stop recording now. And thank you all for participating. Sorry for the technical challenges. I have issues with my headphones from time to time, and they always happen with Zoom. But anyway, I hope that you were able to catch the ideas of LCA, of like how to get started, what to do with OneClick LCA, how the software works, and so on. So just go there, create your accounts, start your projects, and start experimenting. So thank you, and I will now stop recording.